Hello everyone and welcome to our second test for angles and angle measures. In this test, we're going to have multiple choice questions. So we're just going to select which choice is the best answer for a given question or rather statement if it is not a question. So without further ado, let's now begin. All right, let me just prepare my pen and wait. It's loading. All right, let's go. Whoa, problem. Oh, wait, there we go. Anyway, so we have the first question. What does it mean when you rotate it at 60 degrees? What does it mean when you rotate it at 60 degrees? A, you have rotated 1/6 of a complete rotation. B, you have rotated 1/2 of a complete rotation. C, you have rotated 2/5 of a complete rotation. Or D, none of the above. So the answer here is A. Why A? Remember that 1 degree is equivalent to 1 all over 360 of a complete rotation. All right, let me write that here. Complete rotation. So what does it mean? So if I have 60 degrees, so that means I will have 60 degrees all over 360 or 60 all over 360 of a complete rotation. So yeah, this is the answer. But as you can see, wait, let me just complete my sentence. All right, so yeah, complete rotation. So yeah, this is our answer. But as you can see, these answers are different compared to here. So it implies that it is simplified. You see, 60 and 360 are both divisible by 60. So 60 divided by 60 is 1. And 360 divided by 60 is 6. Yeah, am I right? Yeah, correct. So therefore, it's 1/6. That means you rotated 1/6 of a complete rotation. All right? So it's not 1/2, because if it's 1/2, that would be 180 degrees. Okay? That means you rotated halfway. All right? So next. What are coterminal angles? What are coterminal angles? A, these are angles of reflection. B, these are angles that never intersect each other. C, angles that exceeded more than 360 degrees. D, angles that have the same terminal side and initial side. Wait, this is supposed to be terminal sides and initial sides. Damn, bro, grammar. But please forgive me, but I think you get the point here. All right? So what's the answer? The answer is letter D. Coterminal angles exist if they have the same terminal sides and initial sides. Okay? That is how we define coterminal angle. Like for example, okay, we have a given plane and this is 0 degree, 90 degree, 180 degree, 270 degrees. All right, and we have 360 degree. Okay, then on the second rotation, we have, let's just say this is, yeah, second rotation is 360 degree, 450. What's next? This is 540. This is 630. And this is 720. Okay, so if you start here, this implies that this is your initial side. Then let's just say you rotate it until here. So that means you form an angle of 180 degrees. So let's just say in this rotation, you started in this side, then you rotated until here. So that means you rotated until 540 degrees. And as you can see, on this rotation, you start at the right x-axis or positive x-axis, which is similar to this one. Wait, no, it's the same as this one. And also, it ends at this point, which is also the same location as where the second rotation stops. So that means that 180 and 540 are coterminal angles because they start with the same position, which is this one and this, and ends at that position. Okay, so let's go. Forgive me if I keep clearing my throat because I just drank a coffee, which I think affected my phlegm. All right, so please bear with me. Which of the angles below is equivalent to 45 degrees? Which of the angles below is equivalent to 45 degrees? A, 400 degrees. B, negative 545 degrees. C, 405 degrees. And D, 600 degrees. So what do you think is the answer? So the answer here is letter C. How did I know that? Coterminal angles. All right. So how would you know? You experiment it by adding or subtracting 360 degrees. Subtract it with 360 degrees. So 45 degrees minus 360 degrees. What do you think is the answer? Negative 360 plus 45 will give you exactly negative 350 degrees. Okay, so I think that's fair enough. But as you can see, there is no negative 350 degrees in this question. I mean, in this choices, you know. So yeah, even if you would continuously subtract your answer consecutively by 360 degrees, the answers are not actually here. Now, how about adding it? 45 degrees plus 360 degrees. So if you're going to add here, you will have 405 degrees. So that means the answer is obviously C. So it implies that 45 degrees and 405 degrees are coterminal angles, meaning they may be different due to their signs or numbers, all right? Because you see, uh, in coterminal angles, despite their differences, the values, the signs, as long as they have the same initial side and terminal side, they are equivalent to each other. Therefore, 45 degrees and 405 degrees are the same. Okay? So, if 45 degrees is here, okay, then on the next rotation, okay, on the next rotation, this is 405 degrees. All right? So I don't know if this is in the second rotation or third rotation, but again, it implies that they are both in the same position. So therefore, they are equivalent to each other. Okay? Now next. Which of the angles below is equivalent to negative 900 degrees? Again, which of the angles below is equivalent to negative 900 degrees? A, 180 degrees. B, 450 degrees. C, 165 degrees. And D, 505 degrees. What do you think is the answer? All right. To be honest, actually, I'm not that sure. Okay, I think I know. So the answer is 180 degrees. How did I know? What I did in this question is the same way how I answered this question. Experimented by adding or subtracting 360 degrees. So I subtract negative 9, wait, no. I add 360 degrees by negative 900 degrees. So negative 900 degrees plus 360 degrees. So the answer here, wait, I was using calculator, right? So I'm going to use it again. So negative 900 plus 360 will give you negative 540 degrees. And you see, it's not that actually enough because here there's no negative answers here. So that's the first thing that I noticed. And second, it's actually very far from these choices. So I'm going to continuously add it with 360 degrees. So 540 degrees plus 360 degrees. All right, the result here, hold on, plus 360. This is negative 180 degrees. Okay, it's not even close enough in here. So I'll do it again by adding 360 degrees. So here, adding it with 360 degrees. Wait, for a second. Sorry for the inconvenience. I accidentally hit my phone. So yeah, I'm glad that it didn't crack, if you know what I mean, because when our phone usually falls, it cracks, right? And yeah, I'm glad that it didn't crack. But anyways, let's begin. Sorry, let's continue. So 360 minus 180, we will have exactly 180 degrees. All right, and yay, that's it. We already got our answer. So negative 900 degrees is equivalent to 180 degrees. So that's it. That is our answer. So the answer here is A. All right. So next, what happens when an angle was formed due to a clockwise rotation? What happens when an angle was formed due to a clockwise rotation? A. The angle will be negative. B. The angle will be positive. That's for the A. B. The angle will be negative. C. The angle will be 0. Or D. Both A and B. Well, the answer here is B. Okay. This is actually our first discussion about degrees in radians. All right. So let's just say this is your initial side. Once you rotate on a counterclockwise, your angle will be positive. However, when you start rotating clockwise, then the angle will be negative. So the answer for that is negative. All right. So what happens when an angle was formed due to clockwise rotation? The angle will be negative. Okay. Next question. Radians is another way to measure angles. The unit for this, however, is unitless, despite the fact that we use rad to represent a number that is an angle. Why is it unitless? Or in other words, why is it that it has no units? Again, radians is another way to measure angles. The unit for this, however, is unitless or no units involved, despite the fact that we use rad to represent a number that is an angle. Why is it unitless? A. Because when we get the angle in radians by dividing the arc length that is intercepted by the central angle by the radius of a circle, their units will be cancelled. B. Because angles are not meant to represent themselves with other units such as meters, inches, etc. C. This question is wrong. In fact, radian is one of the unit conversion used in angle measures. Therefore, it is not unitless. Or D. This question is wrong because it is impossible for this angle to be unitless when we use rad to represent this angle. All right. So which do you think is the correct answer? The answer is A. All right. What's the formula again in getting the angle but in radians? It is in theta is equal to S all over R, where S is the arc length of the circle that is intercepted by the central angle, and radius is basically your R. All right. So suppose this is the circle. Okay, this one is the S, and here is the angle, and these two lines are radii or radius in singular. So you see, whatever you're going to divide the arc length by the radius, the units will be cancelled. All right. So let's just say, for example, that your arc length here is 1 meters and your radius is also 1 meters. So divide them both sides by 1 meters because arc length is 1 meter and your radius is 1 meter. So yeah, the answer is just 1. All right. But here's the thing though. What if we have kilometers? Like for example, arc length is a kilometer. Let me change this one. Then your radius is a meter. The answer is yeah, it's still possible. It's still possible to cancel out. In fact, if you're going to multiply or divide a number or add or subtract a number, you must have the same units. Okay? It's just like this. X plus X. What do you think is the answer? The answer is 2x, right? Because you have two x's. X squared plus 4x squared. What do you think is the answer? The answer is 5x squared. Because there are 5x squareds. 1 here and 4x squareds given. How can you add x squared by x if these two are not even in common, right? You can simply combine these two if they are similar terms. Just like this one, x and x squared and 4x squared, these two are similar to each other. However, for this case, you can't. Now, similarly, let me erase this one. You cannot just simply add 1 kilometers by 1 meter. You need to make them both equal to each other. You can make this into kilometer, okay, so that this one can add to this number, or you can make this kilometers into meters so that this one is in meters, this one is should be meters, and you can add them together. I think you get what I mean here, meaning both of them should have a common units. Otherwise, you cannot combine them, whether by addition, subtraction, division, or multiplication. All right? So the answer for that is A. Okay? So next. Why the given angle in finding the arc length should be in radians instead in degrees? Why the given angle in finding the arc length should be in radians instead in degrees? A. The formula of arc length is derived from the formula used in finding an angle in radians. If the angle is in radians as a result, then it should be remain as radians while finding the arc length. B. Degrees is not used in measuring the arc length. C. Radian is unitless, so when multiplied by the radius of a circle, we can disregard radian. D. All of the above. What do you think is the answer here? The answer here is all of the above. Why all of the above? Let's start first with the A. Yes, this one is correct though, because you see the formula of the for the finding the angle, but in radians is this one, right? So here, the representation of the answer here is radians, right? So whatever result you will have here is you will always have radians, okay? Just like what we did earlier. 1 meters divided by 1 meter is just 1, but since it's an angle, so we're going to represent it with radian, right? So that means if you're going to derive this formula, okay, in which we will have r theta is equal to s, this doesn't still change the fact that this should be in radians, okay? If you find the answer here, then if you find the answer here that is in radians, therefore you shall not change its units into, you shall not change its representation. All right. So if you're going to find the arc length, make sure that this theta should be in radians. Okay. Letter B, degrees is not used in measuring the arc length, which makes sense, by the way, because you're looking for the length, okay, of a side. So since when we use degrees in measuring the length, like for example, a square, we just want to measure the length of this side. Since when we're going to use degrees, right? So no, we're only measuring for the length. So therefore, degrees is not used unless we're talking about angular length, then that will be a different scenario. But the length of a side, no. All right? And C, radian is unitless. So when multiplied by the radius of a circle, we can disregard radian. This is true. You know, let's just say, for example, here, earlier we have, what's that again? 1 meters, all over 1 meters, right? So the answer here is 1 radians, right? So let's just say that we're asked to find the arc length. So S is equal to R times theta. So your R, it's 1 meters, right? Yes. Times your angle is 1 radians. Okay. So if you're going to multiply them, your answer is 1 meters, which is the same as the arc length earlier. All right. Why is it so? Because here, since if you're going to multiply a number by anything, we can disregard this radian. Okay, we can disregard that because radian is unitless. Just like this one. If you're going to observe, what's the answer when you're going to divide 1 meters by 1 meters? The answer is 1, right? So there's no unit except that is represented by radian. Okay? So therefore, we can simply disregard radian here, then just simply multiply them. So these three choices, A, B, and C, are all correct actually. So the answer for that is all of the above. All right? So next. Why linear speed and angular speed are the applications of trigonometry? Why linear speed and angular speed are the applications of trigonometry? A. It involves the application of triangles. B. It involves angles. C. It involves angles and arc length. And D. It involves arc length. What do you think is the answer? The answer is C. Okay, it's C. Remember that in the linear speed, the formula is what? S all over T, right? So it has something to do with the arc length. So yeah, sure. Okay. Then we have the angular speed, which is theta all over T. So here, it's not about angular. No. It's not about arc length, but rather it's about angular distance, right? So this is applied in here. Okay. Suppose we have a circular path and then we have an angle here. And let's just say this is the object, travel from here up to this point. Okay. So here you can get your S or your arc length to find the distance traveled by the object. All right. And see, since it's in a circular path, there must be an angle between the two radii. And that angle, if you want to find the speed of how angle was formed from this point up to this point, you will use angular speed to know how fast it forms, right? So to answer that question, it involves angles and arc length. Okay? So yeah, that's it. All right? So now let's proceed to the next question. At what part of physics is applied to linear speed and angular speed? Again, at what part of physics is applied to linear speed and angular speed? A. Two-dimensional motion. B. Circular motion. C. Force. D. Work and energy. What do you think is the answer here? Well, the answer is quite obvious. Circular motion. Okay, circular motion. All right, not two-dimensional motion, force, or work and energy. It's circular motion. I already illustrate to you how linear speed and angular speed apply to a circular path earlier, so I do not need to explain it again. All right. Bottom line, these two are applied to circular motion, which is one of the topics of physics. All right. So next question. What is the relationship between linear speed and angular speed? Actually, I should be putting the word the. All right. So let's try that again. What is the relationship between the linear speed and the angular speed? Much better. All right. So A, they are inversely proportional to each other. B, they have no relationship. C, they are directly proportional to each other. D, they are indirectly and inversely proportional to each other. Wait, forgive me. This is supposed to be directly, not indirectly. Directly. So, what do you think is the answer? The answer is C. Okay, it's C. Why C? Okay, there's one formula about linear speed. Okay, that involves angular speed, which is this one. V is equal to R times W. In math subject, when you encounter this type of formula, okay, we have this variable and then this variable, and we let R as our constant, okay, constant proportionality. If we have this one, it implies that if W increases, your V increases, okay? So that means if your angular speed increases, then your linear speed increases as well, and vice versa, okay? Plus, if you're going to represent it graphically, take a look. Let's just say this is you. You travel in a circular path and you end up here. So you start from here, then you go from here, right? So you see, not only that it involves like the distance between the start up to the point in terms of the arc length, which is this, not only that it involves arc length, but it actually involves angle. Okay, it does involves angle. So not only the arc length was involved in formation of the distance traveled, but also in terms of angular distance. Okay, so here they're actually connected to each other, hence their speed as well. Okay, so therefore they are directly proportional to each other. If the angular speed increases, the linear speed increases. If the angular speed decreases, then the linear speed decreases as well. All right, so the answer is C. I think that is these are the questions for our multiple choice test. Yay, right, we're done. So now guys, this is the second test. And our third test is more on problem solving. So yeah, we're going to solve a lot of problems here. All right. So without further ado, oh wait, no. That sounds wrong. It seems like I'm going to start this third test. I'm going to end this test. Okay. Then we will begin this third test in the next video. All right. So good luck guys and see you soon.